Hi guys, we're going to try a new way of going through these sheets together. So let's see if this works out. But today we are on reteaching 10.8 rotations. A rotation is a transformation that turns a figure around a fixed point. This fixed point is called the center of rotation. So looking here at these two figures right here, the figure has rotational symmetry if it can be rotated less than 160 degrees, or 360 degrees, 360 degrees and fit exactly on top of the original figure. Now, when they talk about 360 degrees, they're talking actually in fourth rotations. So when we see 360, that means it's turned all the way around itself. 90 degrees equals a 1/4 rotation. 180 degrees represents a 2/4 or 1/2 rotation, and then 270 equals a 3/4, and then 360 is equal to 4 out of 4. So meaning they turned this figure a fourth around. They added 90 to it again, bringing it up to 180. Same thing here, 1/4 plus 1/4 equals 1/2. Rotated it halfway around. 270 is upside down right now, but we did 90 plus 90 is 180. 1/2 or 1/4 plus 1/4 is 1/2. Now if we add another 90 to it, we'll get 270. 180 plus 90 is 270. 1/2 plus 1/4 is 3/4. So 3/4 rotation, 360 is all the way around. So a figure has rotational symmetry if it can be rotated less than 90 degrees, or no, 90 degrees, 360 degrees, and fit exactly on top of the original fixture. The figure below has rotational symmetry. For a rotation of 90 or 180 about its center, the figure is exactly on top of itself. Now here, they talk about how do you take graphed points and do a rotation, but I'm going to show you how to do it because what they tell you is not the most helpful. So I'm going to demonstrate that on example 4, 5, and 6, but let's look here at examples 1, 2, and 3, which have to do with rotational symmetry. Does each figure have rotational symmetry? Meaning if we put a dot in the center and we turned it and we turned it and we turned it, would it stay in the exact same position? And the answer is yes. With a triangle, we can move it any way and the triangle will continue to just look like a triangle. So yes. However, if we put a dot in the center of this figure, this box is going to change. It's going to start with being on top, but now if we move it to the side, if we do a 1/4 rotation or a 90-degree rotation, now this little box is on the side, it's on the bottom, other side, and at 360 it's back to where it began. But it doesn't mirror. As it goes around itself, this changes relative position and the image shifts in the way it appears. If we put a dot right in the center here, so this one's a no. If we put a dot in the center of these 4 hearts, any way we turn it, we still have heart on top, side, side, heart on top, side, side. So nothing is changing as it revolves around itself. So yes, this has symmetry. Anywhere it goes, it stays the exact same. But what do we do when we have rotations? That we have a pre-drawn figure, triangle ABC, and we're told to draw an image of the figure after each rotation around point O, so around the origin. We want to take this figure and rotate it counterclockwise into each of these boxes as it asks. Remember, a rotation is a transformation that turns a figure about a fixed point. So our fixed point is the origin, point 0, and we want to know what will this figure look like if we rotate it 90 degrees, which is a 1/4 rotation, so taking it from this box to this box. What will we have to do? What will the new figure look like? Now I'm going to get out an index card and I'm going to show you why I'm going to use this. We have points A, B, and C, and we're going to have to transfer points A, B, and C into the second quadrant right here, which means I'm going to need to come up with my new points. I need to know what my new points for A, B, and C are going to be. So I'm going to label each of these. So this is question 4. And the way I'm going to do this, so notice that I have an arrow pointing into quadrant 2 because we're going to do a counterclockwise turn. But I'm going to do the opposite now. So I'm going to have to do a 1/4 turn this way, but the way I'm going to find my points is to turn my paper 1/4 a rotation the opposite direction from the way I'm going. So I'm going to find counterclockwise, so I turned my paper clockwise. And now I'm going to look at my shape, A, B, C, and just write down the exact points as they are. When I rotate my paper back, you're going to see that I actually have the points for when I turn my figure 1/4. This point for A will be my new point for A. So if I look, X is 0, Y is 1. So for A, the point is 0, 1. Oh. There we go. 0, 1. Now let's look for point B. B is at -1, -2, -3, -3, +1. C, X is 0, 1, 2, 3, 4, 5. C is at 0, 5 when I turn my paper a 1/4 rotation. Let's turn it back to center, so how it was, and now they're saying rotate 90 degrees. Now, I've already done my rotation. I've already rotated my paper, and I've already come up with my new points. So let's graph it now. A is at X is 0, Y is 1. So A is right here. B is at -3, 1. So 1, 2, 3, +1. Oops. 1, 2, 3, +1. Yep, right there. And now C is at X is 0, Y 5. So 1, 2, 3, 4, 5. And now I have my new shape. I rotated this figure around my center point with a 90-degree rotation by turning my paper and just writing out the ordered pair from my original shape after the turn. So now I have a rotation of 90 degrees. 90 degrees is, remember, a 1/2 rotation. So I'm going to go 1, skip this box because that's 1, and then 2. Again, it's going to be a 1/2 turn, so this box right here would be a 1/4, 2/4. So my figure is going to go in here. And I draw that just to let me know this is where I'm graphing my point. And now remember what I said, we drew the arrow going counterclockwise. And so now we need to turn our paper the opposite direction to look at our figure to count our points. So that means I'm going to turn it this way. I've turned my paper 1 time, so 1/4. And now I'm going to turn my paper 2/4. And I'm going to do the exact same thing. I'm going to look at my original drawing, but given the shift in my paper, I'm going to see what my ordered pair look like for each of my original points. And as it turns out, by rotating your paper, looking at your original shape will tell you what your ordered pair will be for that given rotation without even changing anything. So if I look at A now, these are still going to be my positive numbers. Positive numbers are always to the right. Negative numbers are always to the left. So I am at X is -1. Y is 0. Right? -1 doesn't go up or down, so Y is 0. Let's look at B. B is at -1 as well. -1, then 1, 2, 3, -3. And let's look at C. X is -1, -2, -3, -4, -5. And I don't go up anywhere on my Y, so -5, 0. Turn my paper so it was as we started, just kind of facing up. And now I'm going to look at the points that I wrote. I already drew my arrow, so I know my figure is going to be in here, but let's see. My first point for A is -1, 0. -1, 0 is right here. B is -1, -3. So -1 already here, down 3. 1, 2, 3. And now C is negative 5. 1, 2, 3, 4, 5. There we go. And I have my new figure. Again, by turning my paper halfway around the opposite direction and just checking out my ordered pair for my original figure, I was able to figure out what my new ordered pair will be. So number 6. And again, 90 degrees is the same as a 1/4 rotation. 180s is the same as a 2/4 rotation, or 1/2. And now 270 is 3/4. So a 3/4 rotation. So 1, 2, 1, 2, 3. Our figure is going to go in there. Again, 1, 2, and then 3 into that third, or I guess it's technically your fourth quadrant, into your fourth quadrant. All right, now again, because I want my figure to go this way, I'm turning my paper the opposite direction. So 1/4, 2/4, 3/4. And now I'm going to write out my ordered pairs. So looking again at my original figure, what is A now? A is now 0 on my x-axis, and it's -1. -1 down. Boop. What's B? B is 1, 2, 3, so a +3, but then down 1, so +3, -1. Let's look at C. X is 0 for C. It's not going to the right or to the left, but it's down. So 1, 2, 3, 4, 5. Down 5, so it's -5. Now I have 9 new points. Turn my paper straight up. I drew an arrow knowing my figure was going to go right here. And so now I'm going to graph it. A is 0, -1. So 0, -1. B is +3, -1. So 1, 2, 3, +1, or sorry, -1. So it is right here. And now C, X is 0, but Y is -5. 1, 2, 3, 4, 5. Draw my dot. Boom, boom. There's my new figure. And I have rotated the same triangle into each of my 3 quadrants simply by turning my paper and writing down my points after each turn. So with that, you may begin your homework.